I know you were kidding. Okay. So, how's everybody feeling about the immersive weekend? Pretty good? A lot of material in a relatively short period of time. One of the things that we're going to start doing, starting with the next immersive weekend, is something called the hot seat. So we get to know each other a little bit more. We'll pick some people at random, 2 people on Saturday, 2 people on Sunday, who'll get up and talk about themselves for about 5 minutes or so, 5 hours. And that's usually pretty good. And then we call it hot seat because we get to ask you any question that we want to ask you. You don't have to answer it, but we get to ask it. So we'll start that at our next weekend. And so, now at this point, we have an application. Either you finish up yours far enough, or you can actually grab one from the repo where it's definitely at a stage where you can have a fair amount of tests for it. And so that's what we're going to start looking at here. We're going to start looking at some different types of tests that you can end up writing to test different things, which tests are more effective, and that's what we're going to take a look at now. So these are all war stories that actually some of these could even hit kind of close to home. These are all situations that you run into where you end up dealing with legacy code, you end up blaming it on somebody else, you end up running into
who doesn't work there anymore. It has to be somebody who doesn't work there.
Of course, yes. So, you also run into situations where, you end up, because boss says, hey, look, we got to make this change, you end up doing an emergency push that ends up screwing things up. These are all sort of excuses that you run into for basically reasons that you don't end up testing, right? You end up rushing to finish it. We'll say after we get it done, we'll end up, doing our testing. It's just a small fix that we made, so no reason to really end up writing any tests for it. Don't worry, we didn't need to test it because there's QA that'll end up testing it for us, give them the responsibility.
Why is that called spray/pray?
Just writing whatever code and hoping. Well, I'm not going to get into that. I'm being you also have, this idea of, hey, look, this part of the code is so screwed up that we can't possibly write tests for it because only this one guy knows how to maintain it. Yeah. So there's a billion different reasons that you can end up coming up with for not writing any tests. But it's important to have tests, and tests end up providing a number of benefits. So one of the things they'll do is that they'll ensure that your code is working, your changes are going to end up working. It also gives you some assurance because if someone ends up changing something, right, that ends up breaking the test, it might be desired behavior, right? But they're going to have to go in there and look at it, and they're going to have to fix the test. Very common. Look, I added that feature. Well, are you done yet? Well, no, I just have to fix some of the text that broke by adding that feature. That happens. That's not necessarily a bad thing. That's just keeping your test suite up to date. The other thing that it also does, if a test is written correctly, it really serves as a documentation for the code in a lot better way than comments work. In code, sometimes you are going to put comments in to explain what's going on, but comments end up getting outdated. Tests shouldn't get outdated because if they're outdated, they should break. And you usually don't let people merge code into your code base until it ends up passing the test. It's also, it's going to make if there are calculations that you're doing, you could run different scenarios, so you can things are going to end up being more precise. Really, this is, I think, the critical part of it. There's a high correlation between testable code and maintainable code. So if you start going in and writing your tests, and your tests are, one of the things that happens is that you end up writing your tests and you find it's hard to test. it's usually hard to test because your code is not that testable. And what ends up happening is that you go, all right, well, let me sort of make my code a little bit more testable. And you find out when you make your code testable, it's also going to be more maintainable. There's going to be less moving parts. Usually when there's problems testing code, it's that there's too many dependencies that the code has. And that makes testing hard. So if you end up pulling out those dependencies in order to get your test to pass, what you really end up, you're not just adding tests, you're actually improving your code base. So it's really something that has become critical. And so the big takeaway from this slide is that there's a history of testing. And the biggest change that you see is really, there was at one point when you had these sort of scriptable unit tests that would end up running. The biggest change that I see in testing is really this whole idea of test-driven development, where companies are not going to be what developers used to do is they would end up writing their code. They would basically smoke test their code. So they would go in and run through it to see if things worked, and then they would hand it off to QA. And QA would end up coming up with bugs that were in the code, and they'd have to run back and fix things. And you sort of constantly going into these circles, because then you would do a fix would end up breaking something else.
Sorry, QA, that's
quality assurance, yeah.
And so those are going to be like people like me, right?
They're people that they're quality assurance engineers. Right. I think that it's becoming a lot less vogue at companies to have them. A lot of companies just don't have them anymore. And the reason they don't have them is because developers are writing their own tests. And so the tests are getting written as the development is done. Very often it's a requirement of the development. So that when you're in in one of the CTO lectures, we cover this, some sort of agile process where you're sort of moving tasks across a board until they're finished. Like part of, is that a dirty look with agile? No one really does agile, but
people starting to do it.
Yeah, well, I mean, they say they want to do it, but it never quite works out that way. But in the end, I think one of the things that becomes important is that the whole development environment is changed. I mean, the development environment used to be done in a way where you'd get a booklet of what all your wireframes of what things would look like, and you'd have months to end up building as a waterfall method. And then when the developers were done, they would end up giving it to QA. And by the time things are ready to roll out, it was already outdated. So now what ends up happening is things are built in smaller pieces. And part of the building things in smaller pieces to be able to build them in a way where you can actually build the code and have enough time to end up writing the tests. And again, you're in the end, what you're getting is you're getting a code base that is both maintainable and testable. And those things are really intertwined with each other. So really, when we end up talking about a big chunk of the full stack developer, right? The full stack developer is, part of the full stack developer is, hey, someone who is, people are not siloed as much anymore. So it used to be a lot more common where there was someone that was just working on the database layer of an application. And literally you had people that were working on database, then you had other people that were working on the back end, and then you had things that were handed off to the front end. And then you had QA that was doing the testing. The whole idea of a full stack developer is that the full stack developer is not only doing the database, not only writing the back end, not only writing the front end, but also doing the testing as well. So it's definitely part of that stack. And when we end up talking about test-driven development, the whole idea of test-driven development is to let the tests end up driving the development. So basically, if someone is really doing test-driven development, and people get they have very strong opinions if they're into test-driven development. There's some places where they only do test-driven development. The idea is, hey, look, specify how you want the system to work, write a test for it, and just keep on writing code till you end up getting that test to pass. I mean, it sounds like, you'd be stuck with this spaghetti, but as you end up writing some of your tests to pass, you go, oh, look, here's another component I have to create, and I'm gonna end up creating tests for that. And we'll talk about what the sort of different levels of how those tests end up connecting. So again, the whole idea here is that if you start out with some version of a test, right, you're going to have tests that are built into the system because that's going to be driving your result. What you're basically doing is describing what you want the result of the system to be, and you're writing the code to get to that point. Whether or not you end up doing test-driven development or you end up writing tests, either way, it's definitely an improvement over not having it at all. So the whole sort of process for doing this is that you end up adding a test, and it's a loop cycle, right? If the test ends up passing on the first shot, which usually it doesn't, right? You go back in and you end up writing another test, and you sort of keep on going through this process. It's they call it a red-green refactor. So you go from red where your test fails, and it's the idea is, hey, look, don't think about everything you have to do. Don't get the perfect code, okay? Get the test to pass. Even sometimes, you hard code data to get your test to pass. And so, all right, at least I know what data it is that I'm going to be expecting, and then you end up writing out the test with code that is actually working to get it to pass. And what ends up happening is that once you end up getting the test to pass, then you can go back and you can say, this is not quite written correctly. I mean, I see, maybe it would be a little bit nicer if some of this stuff was refactored. I see I'm doing this at 2 places in the code. Maybe I can pull this out. I can put this into another module. And what you end up doing is you end up refactoring the code. The way that you know whether or not you did it correctly is whether or not your tests end up passing. So one of the things that's very nice about writing tests is that you get a very, you end up getting results you get your feedback loop is very good. This is something that I think is really critical. And I think people end up going down this track, especially with a workshop like the WikiStack. Because what you're trying to do is you're trying to make changes, and you find yourself touching so many different parts of the application. And when things aren't working, you don't know really what the error is, because you've ended up writing a route. You say, all right, well, I want to get this to work. Hey, look, I don't have any pages in my database. So before I have pages in my database, I have to write my route for adding pages. I'll put my form in there, and then when I end up doing that, I'm going to do my post route, and then I have to write my post route, and I redirect. There are so many things that can go wrong in that process. You can imagine if you just wrote a test that says, all right, page can't be saved without a title. Okay? And you go and write a unit test. You bring in your mongoose model, and you go and you try to save it or you try to validate it, and you end up looking at those validation errors. If you felt very confident, you could basically write your model classes, write all the things that you're doing with the model class. My model class should have a find by tag method. Okay? An individual instance of a page class should be able to find similar pages. These are things that you could write with unit tests.
What's a unit test?
A unit test is testing out a small piece of the code. Okay? So in this context, when we say unit test, it's testing out a very specific model.
So far what we've been doing is more like test-driven assignments.
Both. Okay? When you end up looking at it, it's a very, very good point. You can do this again. In your test-driven assignment, if you remember, you ended up testing out your to-dos model. Okay? That would be a unit test. Then you ended up going in and you ended up testing the router. Okay? That's one level up from a unit test. You might call this a service test. Okay? Sometimes we also call those routing tests as well. And if you imagine that what you end up having, the reason why those tests become a little bit harder to do is that if you're going to write your routing tests, you have to make sure that you have some to-dos in there to test. There's a little bit more setup in order to do it. So at a bare minimum, you should make sure that you get a unit test. But just sort of think about this for a second. All the amount of time you went back and forth, you're going through that click path. All right, I got to go to this page, I got to listing page, I go to this, and you're spending half your time clicking through something. And all these different things could go wrong. Imagine if you nail down those model classes right at the beginning. Then, as far as you're concerned, it's a black box module. You're very, very confident in the way it's going to work. And if you end up adding some functionality to it, you could do it. You have a test for it, okay? And on top of that, it just makes the development. There's a bit more setup to do it, but it makes the development process so much easier because it becomes easier to just get to that green stage where if you're doing what you're doing, basically the testing you're doing, which is not you're constantly doing smoke tests. By going in, you see how many times things break. Oh man, I populated the author in that. How many people went through that and said, I populated the author in that method, but I forgot to populate it in this other method, right? And so you're constantly sort of going in circles there. And then if you have something in your unit test that says, hey, look, this is going to get all my pages and populate all the authors, you just have to remember to end up using it. So this talks a little bit about the cycle, but what I really kind of want to go into. So this is also the idea of, automated testing is basically using a test suite. Okay, so the test suite that we're going to use, we've used two of them already. We've used both Mocha and Jasmine. So you can end up writing tests, although you might not be doing test-driven development. So for sure, you're going to use some automated testing environment, but whether or not you use test-driven development is another story, but you don't want to fall into this category, right? You don't want to be the person that doesn't write tests at all. So whether or not you end up writing your test first or second, you will sometimes just find it is useful to write those tests first until you sort of, you kind of work out some of the kinks of what you're trying to do. I mean, imagine if you're sort of building something where you're doing some calculations within a web application, and you got to go in and sort of fill this format every time you see if those calculations work. That's going to be a drag as opposed to pulling that stuff out into a module and doing your calculations within that module, testing them to make sure that they end up working. I mean, even to some degree, like when I was doing that sort of gulp seeding, that was giving me some very quick feedback on whether or not I could populate things correctly. So that might not necessarily be testing, but those tasks that I put in that gulp task, that would be something you would maybe use for testing. So before you ended up going in and testing out your routes, maybe you would seed your database with this, with some fairly simple data so that you can test that your routes end up working properly. So in terms of testing, you've seen this already. So this is not stuff that's new to you, right? This is the whole idea of setting up your tests and these keywords of, describe, it, and expect. And those are the major things that you end up seeing in tests. And I think it's definitely less complicated to you guys because you've seen it before. So, when we end up thinking about this, our labels are used in our describes and our its. And one of the things that happens when you have an output from the test, you can set up your output so that it reads very nicely, right? We're describing kittens. In particular, we're describing how they eat, okay? And when they do end up eating, it's going to end up returning young, right? So you have this, in the testing environment, you have your labels, right, for your tests. And these are going to be the strings. And you want them to be descriptive, okay? You want it to read like you're reading a story.
Is this going to be the same for Mocha and Jasmine?
Exactly the same. Mocha and Jasmine look exactly the same. We'll talk about what the differences are between the libraries. So we have our labels, and we also have these callback functions, okay, which are going to allow our test to run. So, if you have errors within your tests, it doesn't blow up your test suite, it just ends up failing your tests. So all of these are done in the form of callbacks. That's how these things end up getting nested. So the second you end up writing and describe, immediately give it a label, put a function after it, and give yourself some room to work. Same thing with an it. And then you have your assertions, right? In this case, we have expect. Now, Jasmine has expect built in to its library. Mocha doesn't. Mocha is a lot more configurable, and I think that's why one of the reasons why people like Mocha. It seems to be gaining a lot of traction in terms of testing. And that's what we're gonna end up using for the workshop. So this syntax here that you're looking at, this would be, so Mocha doesn't come with an assertion library. This would not be Jasmine, this would be a Mocha test, because if you're doing this in Jasmine, I think there's just a 2 equal method that you end up using. So we'll talk about it a little bit more, but Mocha doesn't come with its own assertion library. You could use different ones. The one that we're going to use is something called shy. You get it?
Kind of.
Whatever. Okay. So assertions really, you think that they're a little bit more complicated than they are, but they're really just things that end up throwing errors. So, if you wanted to write your own assertion method, you could basically pass in something, and if that thing that you pass in is not true, you end up throwing an exception. Right? At its base level, that's what assert does. In fact, if you wanted to use the assert method is actually built into Node. If you do require assert, you could do an assert and give it a condition. So here, if we had this math library and we wanted to test out adding, we would do an assertion that result equals 3. And that's really what's sitting underneath all these different assertion libraries. They just are done in a way that where they're a lot more readable to work with. The tests themselves end up reading like English. So there's a couple of different levels of testing here. Now we're calling these unit tests, service tests, and acceptance tests. There's a little bit of overlap between them. When we if I think about testing, think about a unit test, I'm thinking about testing out one module. Okay, so a good example of a unit test would be our mongoose models or our SQLized models. I don't know, maybe if we ended up writing some library that was supposed to parse text in a certain way, maybe we would end up writing unit tests for that. But you could just sort of imagine if you wrote, let's just say what you were trying to do is that you were writing code that was making some API call to get some data back. You expected that data to be in a certain format, and then you were going to parse that data to get other objects. Well, if you ended up writing sort of big spaghetti code where one function was doing everything, that's going to be a little bit tricky to test. Okay? So right off the bat, if you start thinking, all right, well, what are the different pieces here? I mean, I've got this one piece that's going out and making an API call, okay, that's getting a result. I've got this other piece that's going to end up doing the parsing. So then you can say, all right, well, let me create a module that's just going to do the parsing. I don't care where the text comes from. I don't care if it comes from an API call. I don't care if I end up reading it for a file. Somewhere along the line, I'm going to get this text, and I want to make sure that I can parse it out correctly. So that would be an example of a unit test. If we sort of look at the pyramid here, a service test is going to be closer along the lines of something like a route, okay? So where a service test is, where there's some dependencies that are going on there. It's one level up from a unit test. We'll talk about how things can actually be stubbed out. So for instance, writing a test that actually hits an external API is a bit of a disaster because you don't have control over that API. So if you're going to end up doing that, one thing about tests is that they're supposed to be very consistent. You don't have control over this external API, then writing a test and actually interacting with that API is not going to make a lot of sense. But putting some sort of modules together might end up constituting a service. So maybe there's some business logic that we end up wrapping around our mongoose models. Maybe there's some something we end up doing with our pages in terms of business logic. Maybe we could put that in a separate module, and we could end up testing that out. I think from what we've done so far, the two levels that you've seen would be unit and service tests. So when you end up doing that assessment, the service test would end up being the routes. The unit test would be when you were testing it to do. The acceptance test is a little bit different. The acceptance test more reads like a story where it says, as a user, I should be able to go to the home page. I should be able to log in. I should be able to add a page. When I click on save, I should see that the page is added. And that becomes a whole process, and there are frameworks that allow you to do that. They're the hardest to write and the hardest to maintain. And you can see it, because when you're doing this workshop, that's kind of what you were doing, right? You were sort of your own acceptance tester by going through, and you can have errors at different stages of the process, and you have to go through the whole process every time. The reason why the acceptance tests get kind of brittle is that it takes very little to have them break. So literally the way that they work is that you have some headless browser that's running in memory, and you say, hey, look, I expect this page, and the headless browser can actually go and find links and click the links and that sort of thing. So go find this link by this classmate, right? And it finds a link and it clicks through. But then all of a sudden the designer is working on the front end and they change the classmate. They don't expect anything to break. And in fact, nothing does break when someone actually uses the application. The only thing that breaks is the test. So that since they have all those moving parts, those acceptance tests end up getting very brittle. So there's also the whole idea that you have testing on the front end and on the back end. So now we haven't done it yet. It doesn't mean all that much to us. We're not dealing with objects on the client side. If we were dealing with objects on the client side, then we might have, unit tests that we could do on the client side. It might be something close to, services that we have on the client side. I don't think really I know what acceptance tests would be on the client side. Acceptance tests are really going to be managing both the server side and the client side. That's the whole idea of the acceptance test. You're going through the entire process. And sometimes, if you are going to write an acceptance test, you do it for very critical parts of your application. I mean, it's very important that someone should be able to get to the order page and click on order, and something is supposed to happen. And without that, you're dead and buried. Then write an acceptance test for that. Logging into the application, that's something that you want to have. You don't mind it being brittle because it's just so critical to have that you're down without it. Being able to load the home page of your site, that's a valid acceptance test.
Is there like a mock library that's popular to use to external?
We'll talk about it. Okay. We'll talk about it. So the area that we're going to focus on in this workshop is going to be the back end. Literally, it's exactly the same stuff, but a bit more complicated than what you ended up seeing in the assessment. Right? The assessment was just data that was sitting in memory. Now you're going to have data less. Now you're going to have data that's in a database. The value tests are going to be exactly the same. The only difference was we ended up just looking at JSON data here. We have posts that we're going to do, and our data ends up going in as URL encoded data, which is going to be a little bit different. But again, you can sort of imagine, you've written some of these methods. You can imagine if you have a database with a couple of different pages, and you have 2 pages, and one of them has a tag of food, right? If you end up saying, hey, look, page object, maybe the tags by find by tag name food, then you should end up getting that page back. So there's always going to be some setup that you're going to do when you end up writing these tests. And all these frameworks have this idea of, before I end up running my test, let me do something. There's also the idea of things being asynchronous. So we'll find out that there are basically parameters that get passed in that says, hey, look, I'm not going to run your test. I'm not going to run your test until you tell me that you're done with your setup. Okay? So you'll end up seeing this when you end up going through the workshop. So in the end, this is all things that we spoke about, is that we want to try to write tests it statics and methods. They call it class methods and instance methods, but it ends up turning out to be the same stuff. So again, what you want to do is that you want to write tests where you can end up isolating your tests, right? And if you can end up writing those tests easily, then your code is going to be a lot more maintainable. When we think about the frameworks that we end up using, so it's interesting. I know a few folks that are, if people heard of Pivotal Labs, Pivotal Labs does a ton of testing, right? It's basically all test-driven development. And they literally pair the entire day, sit down, write the test, get it to pass, write the test. I mean, part of the reason why they do this is they do consulting, right? And they want to have this, they want to be able to hand off this code base, and they want it to be maintainable. They want other people to be able to jump on it. So by having the test, there's some level of best practices that are going on. So they ended up coming up with this Jasmine framework. This other framework, which is Mocha and Chai, is a bit more flexible, reads a little bit better. People like it a bit more, but there's some other dependencies that you end up pulling in. So Jasmine on its own has their own expectation library. Jasmine has their own spies. With Mocha, you end up piecing these things together a little bit more. I mean, if there was any sort of hard and fast rule, it tends to be that for front-end tests, at least, people still tend to use Jasmine a bit. But for anything that's sort of node-related, they end up using Mocha. It's not that you can't use Jasmine. It just seems to be the way that things sort of naturally have happened. So if we end up thinking about doing some model testing, right, this is no different than we end up looking at before. Here we can end up, specifying some value on some object, and, we end up calling some method based upon some property of the object, and we end up, expecting our results. So that whole idea of setting things up, and something that you might end up doing is that, maybe sometimes even this will end up getting moved down into what would be a before block. So you basically set everything up, and in your it, it's very, very clear as to what you expect to happen, right? This is, your it is what your goal is, okay? So, if you have, sometimes when I start testing, I'll literally say, all right, well, I'm going to test out a model called user. And my first test will be it exists. And the test will literally be, I'll say, expect user to be defined. And it fails. And you go write a function for user, that passes. Then maybe you go and you end up pulling it into another module. And then you might start writing tests. When I go to save a user, won't save without some properties. And here things start to get, a bit more complicated, but again, right from the beginning, you're able to write these tests. So routing is a little bit trickier, right? Whenever we start to move up the path of routing, things become trickier. There's a module called supertest. There's also another one called supertest as promise, which incorporates promises a little bit more. It's a little bit easier to sort of have a chain of tests. Just think about this for a second. We have mentioned it. We look at this as being totally magical, right? We look at it, oh my God, how does a super test work? It's amazing. But if you think about it, if we're defining, if we're defining a router in our, we're defining a router in our app, okay? Something that just defines, it's an express app, right? An express app really is a series of routes. That's all it is, a series of middleware. It's a pipeline of middleware. We know we can start a server with our Express app. When you end up using supertest, okay, all that's happening behind the scenes is that you're having supertest start up your server. You can do this on your own. I mean, you could literally go and say, hey, look, before I run my test, I'm going to start my server up. I'm going to have some kind of test server that's set up. I'm going to wait for it to start, and then I'm going to make a request for a page. I'm going to look at what I end up getting back from the page, and that's going to determine whether or not my test passed. Supertest just makes it a lot easier. So that, and people call this different things, but supertest wraps around your Express app and gives you the ability to make get requests, put requests, delete requests, post requests, and then to examine what you end up getting back. So here, if we don't expect that page to exist, right? If you look at the documentation for SuperTest, that first parameter that you can test out is going to be the response code. And here, you can look at both of these, SuperTest and SuperTest as promised. Here, we're actually seeing the idea of passing in a callback to the end. So if your test is going to be asynchronous, if your test is going to end up being asynchronous, and at least with SuperTest, that's the case, you have to call done at some point. If you end up using SuperTest as promised, you don't have to do that. You just have to make sure to return from, you'd end up just putting a return in front of this, and you would end up getting the same result. So again, it's not magic. It's basically a server that's starting up, and you're testing the request to that server. It's definitely more complicated than if you were, writing your model test. There's a bit more setup that you have to do. But literally, like if you wanted to say, hey, look, I expect on the home page, I'm going to see this, you could literally start doing it, saying, hey, here's my agent. Yeah, I mean, you could actually do this if you wanted to with test-driven development. I don't know what app it is, right? So you end up creating your app file. You can do that if you wanted to. So let's actually talk a little bit about the difference between spies, stubs, and mocks. And so part of the reason for this is that, let's say, for instance, I built something in my application. My application, there's some API that I interact with. Maybe it's the Google API. I make a call to the Google API for places, or this is part of it's. Let's say it's in my route. So inside my route, the user is doing a type ahead, and within my route, I'm making a call to the Google API, and that's how I'm getting my results. Now, you don't want to actually touch your Google API within a test. It makes absolutely no sense. For instance, the results can change, that API might be down. This is where you end up using something which would be called a stub, where you want to stub things out in your test. Stubbing is going to be the most common thing you'll end up doing with your tests, as opposed to spies and as opposed to mocks. In some ways where spies were used, when you ended up doing your in foundations, and they were saying, look, call this thing recursively. How did they know whether you called it recursively or not? Right? They did spy. Hey, look, make sure this method is called 10 times. Or make sure this method is only called once. Or this method shouldn't be called, right? So, for instance, if you were going to write let's say you were writing something like our linked list, and you weren't supposed to call push on an array, we could end up doing that to make sure that wasn't getting called. But stubs, for sure, are going to end up getting used a lot. So as an example, you might write a test. Let's say that you were testing some route that was going to be type ahead, where the user ends up putting something in. You're going to expect to get this result. So you would say, all right, I'm stubbing out my call to Google, and Google should end up, I'm going to have it return a collection of 3 geolocations or whatever. And it's canned. That's a canned response. And as a result of that stubbing, then if let's say that your route is supposed to end up doing something with that data or passing, giving you some result, you can end up testing out that result. What you don't want to do is you don't want to go and actually hit that API. So stubs give you the ability to do that. Mocks are a little bit different, where with mocks you end up writing your expectations prior to running your test. I don't use mocks very often. So, and you could look, if you go and do a look online, you can do a search on Stack Overflow, see what the difference is between mocks and stubs, and maybe you'll have better luck than I do, but it still seems to be pretty confusing.
What are you supposed to do if testing how you talk to your APIs and key core that you got to do? Is that just like a standalone test, or something separate?
Well, it's a good question. So if talking to your API, what am I doing here? Recording myself?
Because you could see that as part of your business. Is all of a sudden the API has in fact